In 13.1, we're talking about the area between two curves. So let's kind of talk about the area between two curves. Basically, area, which is designated by the letter A, between two functions. Let's say, or is equal to, let's start, between two curves. I should probably, oh, wait. Between, now I got my head on straight. F of x and g of x is the area under f of x minus the area under g of x. It needs to also always be the top function over the bottom function. So if I have the integral between a and b of f of x dx minus the integral from a to b of g of x dx. Okay, now let's see if we can put it into use. It says we are to find the area bounded by f of x is equal to x squared plus 1. It's also bounded by the line y is equal to 0, and for x being between -1 and 3. So this curve kind of looks like this. Let me get another pen color. Let's say something like this. And let's say 1, 2, 3, 4, and -1 over here. Okay, let's try that again, because that's not the graph of that one. It was a graph of another one that I did. Anyway, this one is the graph of this, and between 1 and 3, so we have, or -1 and 3, my bad. We're looking for the area in here. Okay, let's move that out of the way. Okay, so we're looking at the area equaling the integral between -1 and 3 of the function x squared plus 1 dx, which is x cubed over 3 plus x. We're trying to evaluate that between -1 and 3, which gives me 27 over 3 plus 3 minus -1/3 minus 1. Put all that together, I get 40/3. That's it. Okay, let's play with another one. Okay, we're supposed to find the area. Bounded by the graphs of two functions. F of x is 1/2 x plus 3. G of x is equal to -x squared plus 1. The line x is equal to -2, and the line x is equal to 1. Okay, let's graph this. The graph of this thing kind of looks like this, sort of. Where this is 1, this is positive, -1, +1, and 2. So we're looking at, oh, I forgot the line. That is on 1, 2, 3, 2, 3, and the line is doing this. So one of these is a line and one of them is a curve. So I'm looking at from between there and there. So I want the area of all of this in yellow. Okay, so the area is going to equal to between -2, or the integral between -2 and +1 of, it's always the function that's on top over the function that's on the bottom. So f is on the top, so it's going to be f of x minus g of x dx. So the interval between -2 and 1 of f of x, which is 1/2 x plus 3 minus g of x, I'm going to put a big bracket there, is -x² plus 1 dx, and simplify before you integrate. So the interval between -2 and 1, if you put out to get your like terms together, I get x² plus 1/2 x plus 2 dx, and now we're ready to integrate. This is x³ over 3 plus x² over 2 plus 2x. I'm going to evaluate between -2 and 1. Okay, that gives me 1/3 plus 1/4 plus 2 minus -8/3 plus 4/4 or 1 minus 4. That gives me 33/4 or 8.25. And I got one more for you to kind of show you what it's like if the function on top crosses over the function on bottom and then they switch positions. So this is what I'm talking about. We are to find the area bounded by the function f of x is equal to x² minus x and g of x, which is 2x, and x is between -2 and 3. Okay, the graph of this one kind of looks like this. Let's make it a little bit bigger. So this, let's go different color, red. This swings down, comes slightly underneath, and then it swings back up. Maybe I don't like that one so much. It's a parabola. And then we have the second function, which is a line. So that, let me see if I can get this right, hold on. Between -2 and 3. So we're looking at the area here and the area, it's supposed to cross right before 3. We're just going to go with this picture. It's not quite accurate. So we're looking at the area here where the function in pink is on top, and which is the pink function is g of x, and then on the right hand side the green line is on top, which is the function g of x. So we have to take that into account. So let's do it this way. Let's do two separate areas and then add together. Let's call this one area 1 and this guy area 2. So let's first calculate area 1. That one is the integral between -2 and 0, and I need to take the derivative of f of x minus g of x dx, and that is, well, let's go ahead and put those in. Negative integral between -2 and 0 of x² minus x minus 2x dx, and simplify. So I have the integral between negative 2 and 0 of x squared minus 3x dx. And then we can differentiate. This is x cubed over 3 minus 3x squared over 2. And I want to evaluate between negative 2 and 0. Okay, that gives me 0 minus a negative 8/3 minus 6, which is 26 over 3, which is about 8.67. Okay, let's take the area of region 2. I'm going to scooch over here. Okay, that one, the green function is on top, so I need to integrate this between 0 and 3, and I need to take g of x minus f of x. Remember, it is the function on the top over the function on the bottom. So here we go. Let's plug that in. The integral between 0 and 3, g of x is 2x minus f of x, which is x squared minus x dx. Let's simplify. The integral between 0 and 3 of negative x squared, and that's a plus 3x dx. Okay, might be easier if we swap those around. So let's do the integral between 0 and 3 of 3x minus x squared dx. That's maybe a little easier. So I get 3x squared over 2 minus x cubed over 3, and I'm going to evaluate between 0 and 3. Okay, this time I get 27 over 2 minus 27 over 3, which is 9/2. So now I'm ready. I have area 1 plus area 2 is equal to, I'm going to use a 26/3 to keep accuracy, plus 9 over 2 gives me 79 over 6, which is approximately 13.17. So the area is 13.17. Okay, that does it for 13.1, and I'll do one more for 13.2, and we'll be done for this semester.